Hello students. In previous video we had started with addressing modes in 8085. There are total 5 addressing modes. We were done with direct addressing mode and register addressing mode. We had to start with register indirect addressing mode. So let us move to register indirect addressing mode. What does this mean? Register indirect instructions are always 1 byte instructions. So the instructions which falls under this mode is of or are of 1 byte. Here register pair is specified for addressing 16-bit address of memory location. What does this mean? So let's take the example which is given here. For example, I want to do, let us take these two examples, LXI H0F AFH add M. So the instruction is LXI LXI H 0F AF H, and the next instruction is add M. So what's this mean? This means that just assume at location 0F AF H determines hexadecimal. There is a data stored, for example 25H. And also assume that in accumulator there is some data stored which is, instead of taking 25 I will take 05. Yes, we can take 25 also, no issues, but I want to take 05. In accumulator, for example, I have 02H. This is what is already stored at location 04AF and an accumulator. So these two instructions together, what does this mean? It means that load register pair immediate. This LXI H, 16-bit address means load register pair immediate. As you if you remember, in 8085 there are 3 register pairs. The three register pairs are BC, DE and HL. These are the 3 register pairs available. So here this H doesn't mean hexadecimal. Here this H means HL register pair. So LXI H 0FAFH, this H means hexadecimal, but this H means register pair. So the name of the instruction LXI H, 16-bit, the name of the instruction is load register pair immediate, because HL is a register pair, that's why load register pair immediate. So the meaning of this instruction is, the purpose of this instruction is load this address in HL register pair, or load the contents of 0FAF in memory. When we use the instruction LXI H, 0FAFH, what it's going to do, it's going to load the contents of the memory location 0FAF into the memory. Also, this 0FAF is stored in HL register pair, and HL register pair points to the memory M. So in M, indirectly what is stored? 05, because at location 0FAFH 05H is stored. So the purpose of the instruction LXI H, 0FAF H is it will load the contents of the memory location into the memory, or 0FAF will be stored in HL register pair, and HL register pair points to the memory. The contents of this memory location will be stored in the memory. HL pair points to the memory. So in memory, what is stored? 05H. And add M instruction means A is equal to, the name of add instruction is add register to accumulator. The name of this instruction is add register to accumulator. All these instructions we'll be going to learn in chapter 2. So here just keep in mind that this add M, the meaning of this instruction is A is equal to A plus M. Had there been, sorry, not B, it's M. Had there been C register, add C, then what would have been the scenario? Then here A is equal to A plus C would have been there, because here it is M, so M is memory. So what is there in M? 05, and we had assumed that in accumulator 02 is there. So 02 plus 05 will give 07. A is equal to 07. So this is the purpose of LXI H 0FAF H. So let's see what's written here again. Let's read this again. Register indirect instructions are always 1 byte instructions, like add M. Add M is register indirect instruction. Why this is 1 byte? Because when you will go into the hex sheet, look for add M. There is 86. I had told you the difference in, I've told you why one such instruction is known as 3 byte, why some of the instructions are 2 byte, why some of the instructions are 3 byte. So this is 1 byte because when we look for add M instruction in the hex sheet, there is only one hex code, which is 86, and in hexadecimal, in hexadecimal number, one digit represents 4 bits, so 4 plus 4 8, 1 byte is equal to 8 bits. So the instructions which falls under register indirect addressing are always of 1 byte. Here register pair is specified for addressing 16-bit address of memory location. So what does this mean here, this sentence? Again, here what's written? Here register pair is specified. Can you see? This is a register pair. This register pair is specified for addressing 16-bit address of memory location, because this address is a this is an address. So Register pair is specified. This HL pair is specified for addressing 16-bit address of a memory location. This determines a memory location, the address of the memory location. This is the address of the memory location. So this is the address of a memory location. So I hope this sentence is clear to you. The register pair is specified for addressing 16-bit address of memory location. And LXI H, 0FAF means the contents of the memory location will be stored in a memory M. Now, for example, move A, M. Move memory contents to accumulator. If instead of add M, I would have used move MOV, move A, M. The name of MOV A, M. The name of MOV instruction is move instruction because it moves the contents. Actually not, it doesn't move, it copies the contents of one register into the another register. So again, so instead of add M, if I would have used move A, M, then what would have happened? The contents of memory would have been copied into the accumulator. So for example, here M was 05. This location points to the memory. So this location, the contents stored at this location is 05. So 05s will be stored in the memory after using the instruction LXI H, 0FAF. HL, as you can see here in this example, this we had discussed before, LXI H, 2030H. Initialize HL as a memory pointer. HL points to a memory. That's why HL is initialized as a memory pointer. So, for example, move A, M. So memory contents will be moved, or you can say copied, into the accumulator. But memory location is specifically by HL register pair. Actually, but memory location is specified by HL register pair. Okay. So M was 05. So contents of M memory will be moved in accumulator. So A will become 05 because contents of memory will be copied into the accumulator. So contents of memory is 05. HL is pointing to the memory location. So the contents at this memory location will be moved into A. Okay. Another example of indirect addressing mode is addm. Addm also we have discussed. It adds the contents of memory whose address is stored in the HL pair. Addm adds the contents of memory whose address is stored in HL pair, whose address of the memory is stored in HL, because LXI H, 0FAF, what it does, it copies 0FAF into HL register pair. Why we require HL register pair? Why not only H? Why H and L is required? Why not only L, only H? Because H register is of 8 bits and L register is of 8 bit. So 8 plus 8, 16. Because this is 16-bit address, this is 16-bit, that's why we require register pair. So 0F will be stored in H and AF will be stored in L. It adds the contents, add M instruction adds the contents of memory whose address is stored in the HL pair to the accumulator. That's what it does. It adds the contents of memory whose address is stored in HL and it adds the contents of memory whose address is stored in HL with the accumulator and stores the result in accumulator itself. Okay. The actual program, suppose you want to add the contents of memory location 0F AFH to accumulator, then instruction required are the same which we have discussed. This example is represented with diagram. The address is stored in HL. H stores 0F, L in L, AF will be stored. This add memory location points to a memory and the contents of memory will be added with the accumulator's content and the result will be stored in the accumulator itself. So this was an example of register indirect addressing because here the memory is used and the address of memory is indirectly stored in HL register pair. That's why register indirect addressing. HL register is used to store the address of the memory location. Fourth is immediate addressing. In immediate addressing, what happens is when data, I hope you remember the data. What is data? Or the another term for data is operand, as I had told you the example. 2 plus 3, 2 plus 3 for example. 2 and 3 are data or operand and plus is the operator. So 2 plus 3 is this operator is performing operations on the operands. So 2 and 3 are the operands. So when data is directly transferred to register, then it is known as immediate addressing. So what is happening? Let us start with the example. Here example is given as MVI B, 55H. The example given is MVI B, 55H. So the data is directly specified, immediately specified. What's the meaning of MVI? MVI means move immediate. So the purpose of this instruction is 55. The content will be directly copied into B register. Before we were using move instruction. For example, C, B. Contents of B will be copied into C register. For example, in B, just assume in B 02 is stored. 02 will be copied into C. Contents of B will be copied into C. But here We are directly specifying the content. We are not specifying the register. We are specifying the content. So 55 will be copied into B. So B will be equal to 55H. Immediate. So when data operand is directly transferred to register, then it is known as immediate addressing. 1 or 2 byte instructions are used for this type of addressing. Actually, it's not one, actually, it is 2 or 3 byte. Instead of 1, it should be 3 byte. Make the correction here. 3 THREE 3 or 2 byte instructions are used for this type of addressing. So is this 3 or 2 byte instruction? This is actually 2 byte instruction. Why? Because that content is directly specified. So MVI B comma 8-bit data, because this is hexadecimal number, and in hexadecimal each digit represents 4 bit. Each digit represents 4 bit. So 4 plus 4, 8. So 8 bits. MVI B comma 8 bits. So let us see MVI B comma 8 bits. What's the hex code for MVI comma 8 bit? 8 bit, or you can say 1 byte, because 1 byte is equal to 8 bits. MVI B comma 1 byte is equal to 06. So it is 06H. When we write the program, assembly language programs, then what we will use in hex code for this instruction, MVI B comma 1 byte will be 06H, and then next will be 55H. I hope you remember I had discussed one of the assembly language program with you here. See, LXI H comma 2030H, LXI, that means LXI H comma 16 bit. So let us look for LXI H comma 16 bit. LXI H comma 16 bit is 21. So LXI H comma 2030H is 21, and then next hex code is lower order byte, lower address byte, or upper order byte, or you can say upper address byte 2030 lower address byte, 20 upper address byte. And let us see, move A comma M, move A comma M, 7E. Is there 7E? Yeah. There is no hexadecimal number specified, so this is 1 byte instruction. Only 7E is needed. This is 3 byte instruction, LXIH, 2030H, because it requires 3 bytes to represent this instruction. Okay. Again, if you INXH, let us look for INXH. It's INXH, yeah. Let us look for INXH. INXH. Here it is. INX. There is some mistake, I believe. What's written here? for Annex H is 23H. Oh, it's not given here. There's a mistake in this X sheet. Annex H is not specified. There's a mistake in this X sheet. The correct one I'll find out and tell you. For Annex, if you will look in the hex sheet, for Annex H, the hex code will be 23H, which is of 1 byte. There is no data specified here. No hexadecimal number specified here. That is why it is of 1 byte. If you will see STA 2032, that means STA 16-bit. So let us look for STA 16-bit. STA 16-bit is 32H. So 32H is the hex code, and this lower order byte and upper order byte, 32 and 20. So this STA is 3 byte instruction. So that is why the instructions which falls under immediate addressing are of 3 byte or 2 byte instructions are used for this type of addressing. In this mode, operand is specified. I hope you know what is operand. Is specified within the instruction itself. Here, if we had taken the example of MVI B, 55H, the operand, this is the operand is specified within the instruction itself. So data is specified after immediate mnemonic. Mnemonic, again I will take the example of practical. This mnemonic is divided into opcode and operand. So operand is specified. Data is specified after immediate mnemonic. Data is specified after immediate mnemonic. LXI B, MVI B, 55H. This means move immediate. LXI means load register pair immediate. This example we have taken. Here also the address, the data, the operand is specified in the instruction itself. Okay. This indicates load HL pair with data 52C5H. Here operand 52C5 is loaded in HL registers. So I hope I don't have to explain this LXI instruction. Next instruction is ACI 66H. It means the name of the instruction is add immediate to accumulator with carry. So what is ACI instruction? It adds the data specified in the instruction with the accumulator with carry. As you know, in 8085 there are 5 flags: carry, auxiliary carry, sign, 0, parity. So carry is added with the accumulator. See, in ACI instruction what happens? ACI, for example, this is an example, ACI 66H, and just assume in A, that is in accumulator, just assume that 02 is stored. So The purpose of this instruction is, and it involves carry. Carry means 1. Carry is equal to 1. 1, or you can, 1. So the purpose of this instruction is to add this number, the number which is specified in the instruction, with the contents of accumulator with carry. So the binary for 66H is 8421. How we convert hexadecimal into binary? 8421, which means 0 1 1 0. So 66H will be, and this 6 also, this 6 will also be converted in with the help of 8421, which is 0 1 1 0. So this is 66. 0 1 1 0 0 1 1 0 is 66H, and for 0202 it is 0 0 0 0, and 8421, which is 0 0 1 0. And for carry, which is 0 1, of course, so it will be 0 0 0 0 and 0 0 0 1. So what this instruction is going to do, it is going to add 66H 02H plus carry, which is 0 1. So what it does, ACI comma the 1 byte data, the data will be added with the contents of accumulator with carry. So the addition will be 0 1 1 0 0. This is 66. 0 1 1 0 0 1 1 0 is 66, and 0 2 contents of accumulator will be added with 66H, which is 0 0 0 0 0 0 1 0, and carry will be again 0 0 0 0 0 0 0 1. So the result will be 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 1, 1 plus 1 is 0, carry 1. So 0 plus 0 is 0, carry 1. 1 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1. Sorry, 1 plus 1 is 0, carry will be 1. So 1 plus 1 is 0, 0 plus 0 is 0, 0 plus 0 is 0, and carry will 1 will be here. 1 plus 0 is 1, so here it will be 1. 0 plus 0 plus 0 is 0. If I hope you know the binary addition. 1 plus 0 0 is 1 1 0. So this will be the result will be stored, which will be stored in accumulator. How we can convert it back into hexadecimal? Same, 8421, which is 84 8 4 2 1, and the next 4 digits again will be represented in the form of 8 4 2 1. So 4 plus 2 is 6, and 8 plus 1 is 9. So in accumulator what will be stored? 69H. Okay. So the meaning of ACI instruction is add the data specified in the instruction with the contents of accumulator with carry. So ACI falls under immediate addressing because the operand, the data is specified in the instruction itself. Okay. Next is implicit addressing. In implicit addressing instruction, they are always of 1 byte instructions. Many instructions of logical group belong to this implicit instruction. So what is this logical group? When we will start with chapter 2, there we will learn that those 74 instructions, out of those 74 instructions, the instructions are classified into different groups. One of the group is logical group. So that's why it's mentioned here. The many of the instructions which falls under this addressing mode are from the logical group. Okay. So the example of implicit addressing is complement A, complement accumulator. Complement accumulator means, for example, in accumulator 02 is stored, which is 000 010. So the complement of 000 010 is 1 0 1 1 1 1 1 1. Wherever there is 0, it will be complemented to 1. Wherever there is 1, it will be complemented to 0. So the purpose of CMA is complement accumulator. RRC, rotate accumulator right. The contents of the accumulator will be rotated towards the right. All the constants of the accumulator, for example, in accumulator, same thing, 02 is stored. The binary of 02 is 0 0 0 0 0 0 1 0. Why we are taking A is equal to 0 2? Why not only 2? Because accumulator is of 8 bits. So if I'll take only 2, so it will represent only 4 bits. So I'll have to take 0 2. So this RRC is rotate accumulator right. Rotate the contents of accumulator to the right. So this will be copied here, 0. It will be moved to right. This will be moved to right, which is 1. This will be moved to 1. I mean here, which is 0. This will be moved to here. This 0 will be copied into the carry also, and to this position also. This position. This 0 will be copied into the carry also, and in the carry also, and at this position also. Then this 1 will be copied here. This 0 will be copied here. This 1 will be copied here at this position. This 0 will be copied at this position. This 0 will be copied here. This 0 will be copied here. This 0 will be copied here. this 0 will be copied here, and this 0 will be copied here. So all the bits will be moved to 1 position to the right. So it rotates the accumulator to right. STC means set carry. If carry flag, as you know in 8085, there are 5 flags. One of those flag is carry flag. If carry flag is 0, set carry means if carry flag will be set, that means carry flag will be equal to 1. Set means 1. Even if carry flag is 0, it will set the carry flag. It will make the carry flag is equal to 1. CMC. CMC means complement carry. If carry flag is 0, it will convert it into 1. If carry flag is 1, it will convert it into 0. The difference between set carry and complement carry is set carry always makes the carry is equal to 1. If carry is equal to 1, then it will be 1 only. If carry is equal to 0, then it will become 1. But in complement carry, if carry is equal to 0, it will be converted into 1. And if carry is equal to 1, it will be converted into 0. The address of data is contained with the opcode. I hope you know what is opcode. Same example I am taking mnemonics. Mnemonics is divided into two, opcode and operand. Operand means data. So opcode, here the address of data contained with the opcode. The data is stored in the instruction itself. For example, complement A. That means I have to complement accumulator. Accumulator is specified in the instruction itself. RRC. This means rotate the contents of accumulator to right. So accumulator is specified in the instruction itself. I don't have to specify any operand like I had to specify in this MVI B, 55. The operands were B, 55. Here we don't require operands, we only require opcode, which is CMA, RRC. Here also set carry. Carry is specified in the instruction itself. No operand required. CMC, which is complement carry. Again, carry is specified in the instruction itself and no operand. So in implicit addressing mode is done. So how the instructions are classified into addressing modes? Here, if you read the sentence, there are number of instructions which are classified according to the type of addressing the data. How the instruction addresses the data, depending on that, the instructions are classified. For example, here indirect addressing, how data was addressed. Here the data was addressed how? The address of the operand specified within the instruction itself. I hope you remember the meaning of this instruction, LTA06C2. That means load accumulator with the contents of memory location 06C2H. Just assume that at location 06C2H 05 is stored. So 05 will be copied into accumulator itself. So the address of the operand is specified in the instruction itself. The data, how the data is addressed. The data is stored at location 06C2 is copying into accumulator. So how data is addressed? By specifying the address within the instruction. So direct addressing. So how data is addressed by the instruction, that classifies the instructions into different addressing mode. In register addressing mode, register are specified in the instruction. Basically, in registering addressing mode, mostly the contents of one register will be copied or transferred into another register, or the contents of accumulator will be transferred into a register. So that is register addressing mode. the data, how data is addressed. The data which is stored in one register will be copied into another register. So how the data is addressed, the data which the instruction is dealing with, the how data is addressed by the instruction determines the respective addressing mode. Okay, so this is the end of the chapter and this is very important topic. This is the end of the chapter 1. In so we will stop here. Thank you.